For all those who appreciate the work that we're doing here on Standing for Truth, please hit that subscribe button because we are just getting started.
All right, it looks like we are live, guys, on Standing for Truth, and I am extremely excited because this is the first presentation this week on the Genesis Flood. It is the Genesis Flood week, guys, and we are going to be starting off with Professor David McQueen, who's going to be giving a presentation on the geologic end of the flood. And as we are going to be doing with all the presentations this week, we've got Mike Ord, who's going to be with us on Wednesday, and Sal Jardina on Thursday. Both of those gentlemen have been here before in the past. And Mike Ord is going to be specifically talking about the post-flood ice age. And Sal Jardina will be talking about the evidence from geology that supports the flood. So it's a very exciting week. I'm very excited to have Professor David McQueen back here with us today. So please, everybody, tag me with your questions. We are going to be having a short presentation at first, and then some questions from the audience, and then another presentation and some more questions. So it's going to be a lot of fun. I'm excited. Good to see people in here. Thank you so much for the super chats, the super stickers, guys. I appreciate the support. So that being said, let me bring in our amazing award-winning co-host, George Bond, and Professor David McQueen. Gentlemen, thanks so much for being here. I like it. I like it, Professor McQueen. Gentlemen, thanks for being here. And why don't we throw it over to you for a couple introductions or introductory words. Go ahead, gentlemen.
Okay, I'll start before George tells his first joke. I got dressed with my rock hammer and my hat, my geology field vest, because we're going to go to places like Nebraska and Australia and go all over the world to talk about what happened in the Great Flood. Now, George, and Standing for Truth, I've got a poem that you have to memorize in the next 2 hours. I'll introduce it and then I'll explain it more as the show goes on. 7 troubled kangaroos attacked zebras today in Australia. This is a memory aid for helping us to memorize Dr. Tim Clary's sequence stratigraphy. You know, I've taught you in the past about carry out some dinner, Cambrian, Ordovician, Silurian. Well, I got Mrs. McQueen to help me this morning with the new poem, 7 troubled kangaroos attacked zebras today. The S of 7 stands for the Salk sequence. But so much for new poems. George, what's our joke for today?
To be honest with you, I'm not going to tell a joke today because I've got a froggy throat and I might stuff it up by coughing during it. So I apologize. But I'll have 2 jokes for you next time.
That's very good. I hope
we'll make up for it next time, George.
I hope you're already laughing about the troubled kangaroos attacking the Zuni sequence and the Tejas, but we'll come more to that as time goes on. Let me introduce what George and I are going to be talking about. I'll dispense with my rock hammer for the moment there and comment that we're going to be looking, and I've got my timer running here. For the first 20 minutes, we're going to do an overview of the last 6 months of the flood, what Standing for Truth has called the geologic end of the flood, which is very, very appropriate way to talk about it. We need to start out with some vocabulary so that there's no confusion. Behind me, you'll see the red and the white to honor the Canadian Easter Monday as we think about Jesus's death and resurrection. So there's always an issue that goes back to the Bible. And when I talk in that regard, I'm speaking as a Bible geologist or a biblical geologist. But there's another vocabulary we can use, and that's a vocabulary of flood geology. Standing for Truth is working to find a debate opponent for me in the summer, in July or August, a deep time evolutionary geologist that will debate some of the aspects of what might be called flood geology. This is the idea that's been suggested for really hundreds of years, that the Earth's surface is dominated not by slow, gradual processes, but catastrophic processes. A book has been written called The Nature of the Stratigraphic Record. The author is named AGER. And this gentleman has pointed out for years, and he's not a creationist, that the nature of the stratigraphic record is long periods of boredom, much like a soldier's life, followed by brief periods of terror. And so as we talk about the waters receding during the latter part of the flood, we need to keep this in mind. George and I have talked about the engineering properties of the toy marketed in the U.S. called Play-Doh. Ironically, I've been looking at the rock mechanics of this since my high school days. And it turns out that the way that Play-Doh behaves, and I spent some time this morning robbing my grandchildren of their Play-Doh and kneading it out. It turns out the way that Play-Doh works, the way it feels, the consistency of it, the ability to form folds like this anticline here, or if I turn it over, a syncline. Mm-hmm. That ability mimics the soft nature of the rocks that were laid down in the early part of the flood and then deformed later on. So as we talk about this issue of flood geology, make sure that you're not missing what we're saying here, that if we get a color like this modeled almost igneous or metamorphic looking rock here, and we say that this rock is from creation, traditionally the geologists 200 years ago would divide the Earth's crust into what they would call primary, which is what my little finger is touching here, secondary, that would be rocks formed in the early part of the flood, tertiary, which would be rocks that were formed later on in the flood, and then quaternary, rocks that were formed after the time of the flood. Now, that is a neutral vocabulary that talks about catastrophic deposition of rocks worldwide. And George, in your reading, you've seen this, I hope, stripped of any biblical connotation. Is that correct?
Yes, I have. Actually, I managed to find my university book on geology. It was just called Geology Today, but that was back in the mid-70s, so it's quite old, and I guess they've made considerable number of amendments to that. But yeah, I do remember those sequences that you mentioned.
Yeah. And so let's briefly switch gears now to what the Bible says, and then we're going to switch from flood geology to biblical geology. And our argument here on Standing for Truth for weeks now has been that the Bible is actually a trustworthy historical document. If you go into the court of law, Standing for Truth, and you look at what people say, isn't an eyewitness account always something better than even the best forensics? Do you see what I'm saying, Standing for Truth?
I do. Yes.
Absolutely.
And so let's go back to someone who actually witnessed this and wrote it down. And so let me read the latter part of Genesis 7 and then the first part of Genesis 8 so we can get a Bible geology perspective on this. And the waters flooded the earth for 150 days. Now, this 150 days is the latter part of that first two phases of the flood that we've spoken of. But now let's go to the final geologic phase. But God remembered Noah and all the wild animals and the livestock that were with him in the ark. And he sent a wind over the earth, and the waters receded. Now, keep in mind that God didn't forget Noah. He was actively moving the ark on the surface of the waters all those months. But notice that this begins with a wind that begins to move. And I'll comment in the second hour about some rocks that are a 1 hour drive away from me in the Mississippi River that are wind-blown sediments, pronounced loess, but spelled Loess. But let's keep going. And the waters receded. Now the springs of the deep and the floodgates of the heavens were closed, and the rain had stopped falling from the sky. And so this means that the subterranean reservoirs of water that Dr. Henry Morris talked about from the 1950s on, they were closed up. The continents had already begun to separate in the Mid-Atlantic Ridge area, which would be an example of the fountains of the Great Deep. But keep in mind, as George and I talk about these things, that we're not saying that there was no more volcanic activity. We're not saying there weren't any more ash, huge ash falls on the earth. And as we talk about the origin of coal in this next few minutes, you will see that we're talking about activity that included a lot of things happening in that last 6 months. But let's read on. The water receded steadily from the earth. At the end of the 150 days, the water had gone down, and on the 17th day of the 7th month, the ark came to rest on the mountains of Ararat. And so let's be clear about what facts we have to deal with. A proverb that I've begun to teach is this. The Bible does not tell us everything we want to know, but it does tell us everything we need to know. And so the framework for a year-round flood, year-long flood, is laid in the Bible. And in publications, I often see a question, well, where did all the water go after the flood? And the idea is often an idea that looks something like this. You have mountains before the time of the flood. The model I've worked on for the last 40 years have those mountains to be around 10,000 feet in height. But at any rate, you have mountains before the flood. The flood occurs, and as the waters are receding, you have what is called technically isostatic adjustment. In other words, mountains begin to rise and ocean basins begin to open up. Let's use, for example, the southern Atlantic Ocean between Africa and South America. That opens up, and all that water flows off of the continents and begins to fill these deep ocean basins. Since my good friend is from Australia, we'll talk about what happens between the Indian subcontinent and Australia, Papua New Guinea, all that area, that's opening up, and you have large basins there. So the waters come down, the waters go up. And in our second hour, I'll talk about a very common incorrect argument that people give regarding the Great Flood. They will say, "Oh, we can see evidence of a global flood because we find fossils on mountaintops." I'll give a critique of that in our second hour. In the next 15 minutes, as I lay the groundwork before George asks his first question, we're going to take one part of the United States, and I'll move my map over here so I can show it to you. This mesa or butte here is in the state of Nebraska. If you're familiar with the geography of the United States, this is western United States, and this is an area where this is in an area that borders the state of Nebraska and the state of Wyoming. And it's a national monument called Scotts Bluff National Monument in this part of Nebraska. And in the geography that you've been taught in Australia and otherwise, George, would you call that a bluff or a mesa that I'm putting up there? Is that a bluff or a mesa?
Oh, George, I think you're on mute, brother.
Oh, yeah, it's on mute there. I'm sorry.
I'm sorry. I don't know what they would call that.
Okay. In the U.S., there's two vocabularies. This would be called a bluff by some or a mesa. But why would I even bring this up? It turns out this group of rocks here that you see behind that covered wagon there is a group of rocks that are supposed to be less than 100 million years old. And on the traditional time scale of the evolutionary community, you will see that these rocks fit in what's called the Quaternary period. These are words like Eocene, Oligocene, and so forth. And you'll see our ancestor there, George. Let me get my hand on old Neanderthal man. That's supposed to be our ancestor. But these rocks that I was showing you, and we'll talk about in Nebraska, are supposed to be 30, 40 million years old. And in the way that we've come to think about the rocks that we see in the Grand Canyon and beyond, these would be called late flood rocks, or rocks that are at a boundary that is an exciting part of current research. Here is volume 2 of Dr. Snelling's big book on geology. And George, I thought I'd read for you a section from page 761 that bears on this. He says this as he concludes this chapter on where is the boundary between the flood and post-flood time in the geologic record. He says, vertical earth movements and isostatic readjustments built mountains and elevated plateaus after the Cretaceous, like what I just showed you in Nebraska, while the sea level rapidly fell as floodwaters drained. Now, here comes a point of disagreement. Now, those of you that are critics of young Earth geology will say, oh, this shows that these guys can't agree. No, that's not what it shows at all. It shows that Dr. Andrew Snelling has one viewpoint. Dr. Steve Austin, who has a PhD in geology from Penn State, has another viewpoint. Dr. Tim Clary, that we're going to talk more about. Remember the poem we got to memorize, George? 7 Troubled Kangaroos, attacked zebras today in Australia, as if there's any zebras in Australia. I don't know. But at any rate, when you think about that in those terms, listen to what he says at the end. See, this argues that we're real scientists doing science the way you should because we disagree on details. Listen to this. Continued volcanic activity declined in power and effect as the rates of global tectonic and geologic processes also declined to provide a new stable world safe enough for Noah, his families, and the animals to disembark from the ark. And so Snelling argues that it was after the Cretaceous tertiary boundary that it was the end of the flood. Interesting point. And we're coming up on the first 20 minutes here and ready for George's first question. But I hope you see what we're driving toward here. There's more than one theory among creation geologists about exactly where the end of the flood is. And that should prove to an analytical audience that we're dealing with real science and real competing multiple working hypotheses. Okay, that finishes our introduction, George. What question would you like to put up on the board for us?
Just a statement to begin with. In the example you were showing, David, with your Pleistocene, where the isostatic situation where the land was going up, the ocean's going down. Yeah. Now, if we look at that from the point of view of old Earth geology, there are obviously rivers flowing on the land, and as the land rose, those rivers would gradually erode the land, and you should find massive, and I'm talking massive canyons. So why don't we find these massive canyons if this has been occurring for billions of years?
Exactly. And the point's very well made. These should form canyons as the water runs off. But it's not just one canyon like the Grand Canyon in the United States, or canyons on the Hawaiian Islands, or canyons in Northwest Africa. There are several Grand Canyons around the world, but don't miss George's point here. If we have a billion years of this kind of geologic activity happening, why don't we find a canyon almost everywhere? How in the world can we find flat lying? Since I'm using that for water, I'll pick another color here for another type of sedimentary rock. So here you've got the red, the yellow, and the orange there. We've pointed out that there are knife-edge contacts in Australia and in the Grand Canyon and in Europe. Why would you find this? You wouldn't find it if you've got a billion years of this type of erosion going on and on. Good question, George. What's the next?
Exactly. SFT. I had a sort of interesting discussion with a YouTuber by the name of Matt Smith. I've got some screenshots of some of the questions. I thought they might be interesting ones to tackle during the question and answer period. So if I can share the screen.
Sure.
I've got to remember how to do this now.
The
George
fourth
button going out.
You got it, George.
Okay, there we go.
Oh, he did have it. And then he must have left studio by accident, but he'll be back.
Okay,
in the meantime, Professor McQueen, I do have a question from the audience if you wanted me to.
Please go ahead and give it. Yes.
Okay, so let me pull it up here.
Okay, good.
I did save it, but I lost it in the chat. So let me go.
Okay, no problem.
So here it is.
Okay, good.
A question from Andrew P. Professor McQueen.
Okay, good.
He asks, if Professor McQueen doesn't cover it in his talk, could you ask him about the post-flood boundary, as in where he believes it is, and what are the reasons for believing so?
Okay, good. As I have commented a few minutes ago, I hope you heard it. I think that in many parts of the world, the post-flood boundary is above what would be called Cretaceous. Now, remember the word Cretaceous in the geologic column is given the letter K. Well, that's from the German word chalk. And so around the earth, there are all kinds of chalk deposits in what's called the Cretaceous. And there's the Austin chalk in Texas and so forth. And let me look on my handy dandy chart here. And this is associated with finding triceratops and pteranodons and other large dinosaurs in late Cretaceous. And then you go up into what's called the Paleocene. So that's where I would put it. Dr. Andrew Snelling puts it later on in the geologic column. So there is a discussion. George, you're back. What was that question you were going to read?
Sorry, I pressed the wrong tab.
That's okay.
I'll share the screen again.
Yeah.
Yes, please.
You had us worried there, George. We missed you. Remember, you're the award-winning co-host. We need you here, brother.
That's
okay,
right.
Here we go.
Can you see that?
Oh, yes.
All right, I'll go to this one. What's happening now? Oop. Here we go. He says, you don't need a PhD in geology to know that desert dunes and other desert deposits do not form under roaring flood waters. These require not only time but also dry land. The flood of Noah supplies neither. Okay, so he talks about the red sandstone, the old red sandstone, which looks for all the world like a collection of fossilized desert dunes, was formed in Devonian times. So what I did was, this is an old one. I mean, we've sort of debunked this a number of times, but this is how sand dunes form underwater, and we know that it was water because of the angle of repose. I think David would know what an angle of repose is. It's the natural angle of the material forming.
Yeah.
And just to show you an example, here's a recent tsunami off the coast of Japan, which showed that these sand dunes formed over the course of the tsunami and not the long periods of time secular geologists had predicted. This is observable. This is observable science, Matt.
Yeah, very, very good point. I want to respond to that myself.
Yeah.
I too, in the early 70s, when I went through undergraduate school, was taught that if you look at the sandstones in the Grand Canyon, like Coconino sandstone, for example, it is cross-bedded, evidence of a dune, and therefore must have been a moving body of sand going across the western United States. Well, the kicker to that is when I have gone, and I have hiked the canyon 5 times in 4 years, and I've actually looked at the contact between the Coconino and the rocks above it and below it. What it looks like is this. Let's let the yellow here be the Coconino sandstone. And let me move my model around a little bit. And the contact between these things, I'm sorry, let me say it more clearly. The contact between the Coconino and the units above and the units below is knife edge. You would never get a knife edge contact if you buried moving sand dunes. A far better explanation for this is deposition under moving water. How do you like that response there, George?
Yeah, yeah, it's very, very good. It's an easy one to refute, but I've got a few other ones from Mr. Matt Smith. If SFT hasn't got any from the audience, I'll share screen again.
Yeah, go ahead. Go ahead. We answered one of the audience questions when you dropped out, George. So if you want, share your screen and we can do.
Okay.
There we go.
This is the first one. He says scientific analysis has refuted the key tenets of flood geology. Well, I beg to differ there. Flood geology is contradicted by the scientific consensus in geology. So he's appealing to consensus. Stratigraphy, geophysics, physics, paleontology, biology, anthropology, and archaeology. Modern geology, its subdisciplines and other scientific disciplines utilize the scientific method. In contrast, he says, flood geology does not adhere to the scientific method, making it a pseudoscience.
Okay, let me respond to that. As I pick this trowel up, if you've watched movies involving archaeology, you know this is an archaeologist trowel. And as we go looking at the geology involved in archaeology, I've had the privilege of working on an archaeological dig in Israel, in two different places, near the biblical town of Ai. What correctly should be pronounced. A is silent in Hebrew, much like the word pterodon. You know, the P is silent, George, in the word pterodon. Yep. And pterodactyl. That's why if one comes to your house and uses the restroom, you can't hear them because the P is silent. You see that. But at any rate, let's go back to the serious part. So any archaeological, I'm sorry, I said the wrong word. Any architectural pyramid or building that was formed or was built in the pre-flood world, because we're talking about a 12-month-long catastrophic worldwide flood, every one of those structures would have been knocked down. And so it's not true to say that the evidence of archaeology supports deep time geology. It's actually quite the contrary. When you go digging through those layers, you're seeing the development of civilizations after the time of Babel. Now, the fellow that's asking you these questions may counter-argue. He may say, oh, no. You guys are off base because we're talking about the Stone Age and the Bronze Age and the Iron Age. Well, there's an argument that is not true. But let me tell you something that we would expect, we would predict, and Ms. McQueen let me borrow her bell. This is what she uses when she needs me standing for truth. She rings the bell and I come running. And what about a bell like this? Well, there have been isolated reports in coal seams of objects like this. Now, this is obviously, for those of you that are not in America, this is the Liberty Bell, famous in American history. But people have claimed that they found brass or bronze bells in coal seams. And if those coal seams were laid down, and we can use our Plato model here once again, let's imagine that we get another color here, like this color, and we put it on top of the Coconino sandstone and more layers on top of that. If this is coal, that formed by floating mat of vegetation. Now, we're talking about a huge floating mat. We're talking about a floating mat the size of the state of Arkansas or the Australian state of New South Wales or the whole province of Ontario. We're talking about huge amounts of coal, of vegetative material knocked down by the flood and floating as these waters are receding, and then you would find it in areas like that. You would predict that somewhere you might find human footprints or artifacts like bells associated with dinosaur footprints. And there are anecdotal reports. Now, is there a place that I can go show you a bell and coal today? Not an easy place, but I think you see the logic, George. Is that correct?
Yes. His other point was it's not empirical. I'm sorry, but yes, it is empirical. I've witnessed flume experiments where we've actually actually formed those layers through moving water with those knife edge boundaries that you mentioned, David. So
yeah,
I don't know where Mr. Smith is getting his information from,
right.
But he obviously doesn't know a lot about the empirical evidence that is out there.
Okay, we're 40 minutes into our first hour here, so let me answer Mark's question. Where did all that coal come from? Well, recall what I just said. If we have a floating mat of vegetative material that is not a few square kilometers, a few square miles, but hundreds and thousands of kilometers that's floating on the waters of the Great Flood, as the floodwaters recede, that we know happen, that we're talking about today, those mats of coal would then be deposited on the receding continental land surface. And then, let me use a different color, more rocks would be laid down on top of it, and these would form the compression and the temperature that would form the coal measures. Now, whether it's this hour or next, George has done some very good research on carbon-14 in coal. Now, keep in mind, if these coal measures are supposed to be in rocks that would be older than the Triassic period, in other words, older than 200 million years ago, you shouldn't find any carbon-14 in a coal measure at all, should you, George?
Definitely not. Even their own geologists state that after 100,000, you shouldn't find any measurable C14 in anything. And let alone even in a million years, you shouldn't find any. So, I mean,
like
do you want
me to point out, George, looks like Mark has a follow-up question asking, how did all that oil get so deep?
Okay, let me respond to that, and then maybe in the second hour, George can elaborate more on the research he's done about carbon-14 in coal and volcanic ash and so forth. But let's talk about petroleum deposits for a moment. And let me bring in this poem that we're memorizing. 7 troubled kangaroos attacked zebras today. This is what's called sequence stratigraphy. The 7, S-E-V-E-N, stands for the Salk sequence, which is very, very low in the early part of the flood. And we'll skip the T and the K and the A for right now, and we'll go to the Z, which is a unit in sequence stratigraphy that's called Zuni, and then the T is Tejas, which is the Spanish word for Texas. So that's where attacked zebras today comes from. Now, why would I be emphasizing this? I have taught you before the poem that I was taught 40 years ago about remembering Triassic, Jurassic, Cretaceous. Carry out some dinner, Miss Penny Pearl, to Johnny Clock, Triassic, Jurassic, Cretaceous, to Johnny Clock, the Queen. I was taught this years ago, And so I'm trying to mimic a memory aid like that to give you an introduction to Dr. Tim Clary's excellent book that's called Carved in Stone. Now, how in the world does this apply to petroleum geology? Well, let's go to Western South America and look at his diagram here. Let me try to get it in the field of view. You see, there's Western South America. And notice that if I can move the book correctly, you notice he's got stratigraphic sections there from oil wells in that part of the world. And so in South America, you have an awful lot of what's called Zuni and Tejas rocks there on the western side of Australia. And you also find the other units lower. Now, let's be sure to teach this clearly so that you can have something to think about as we go on, or as we take a break, for example. Now, these words, Salk, Zuni, and Tejas, Tejas, I didn't make my J very clear there. That is a division of stratigraphy that's quite commonly used in the oil companies, and it's called SEQUENCE. It's called sequence stratigraphy. And so sequence stratigraphy is routinely used in petroleum geology. Now, how does that answer Mark's question? Well, if the red layer here is some of that organic material knocked down before the flood, inorganic organisms like clams and snails, plesiopods, gastropods, if they all get involved in this layer and they're buried very quickly as the floodwaters recede, then you have a situation where this layer is cut off from oxidation and it's buried deep, 10,000, 20,000, 30,000 feet. This is called, in the lingo of petroleum geologists, and Standing for Truth, I hope this summer we can get a deep time petroleum geologist to argue this with me. This is called a source rock, and this source rock may be on the edge of a mountain building event where the mountains are bent up in an anticlinal shape like this. Let me move it where you can see it more clearly. So this would be called an anticline here. And so the crude oil, natural gas, and water that's in this layer deep goes up into this anticline, and it's not the systematic application of evolutionary geology that allows petroleum geologists to find crude oil. This is called a source rock. It migrates to a reservoir, or a trap as it's called, and that's where the petroleum is trapped. And now let me find a pin here. And so the stratigraphic section I showed you is an oil well going down through this anticline in 20,000 feet. Can you see it's going all the way through there?
Yep.
And that is the oil well that allows the crude oil to come to the surface. So that's a quick answer to how the crude oil got that deep.
Well, that was a highly detailed and informative answer as well, Professor McQueen. So I really want to thank you for that. Very good answer. Very good question. George, I'll hand it over to you, brother. Go ahead.
Yeah, and we know we need heat to produce that oil. Excuse me.
Yes.
Yeah, we need heat to produce that oil. But the issue is the location of that oil is a bigger problem for secular geologists, because if that oil has been sitting there for hundreds of millions of years under that kind of pressure, you wouldn't expect to find that oil. That should have leaked out many, many eons ago.
Exactly. And let me follow up on what George said there, because it's a very good point. If you look at the classic anticlinal trap, a lot of things happened in 1859. Darwin published Origin of Species, but an American entrepreneur named Drake discovered the first oil well in Pennsylvania in 1859. And he was looking for structures like this. Well, what is the kicker on a structure like this? Let me go back and ruin a second pin by piercing through my Play-Doh here. If you pierce through this rock, like George was talking about, if you pierce through it with an oil well, get it to the correct side, there will be, let me get some of the Play-Doh off the bottom here so you can see. This is the oil well going through. Many of these reservoirs have what's called overpressured shale. So there's a tremendous pressure there. And if the driller is not competent, he will pierce through, and 10,000 feet of pipe will go flowing, not flowing, excuse me, 10,000 feet of pipe will go flying out of the well and kill everybody around. The natural gas and so forth will come up, start a fire that it takes weeks to get out. So what George says is really true. Not only should the crude oil and natural gas have come through, and let's create a fault in this. Let's say we've got a fault in these rocks that's up at the top of the anticline, and George is enough of an engineer to know that if you bend some wet concrete, it's going to crack at the top, and all that crude oil and the pressure there would flow out. So the issue of overpressured shales is a young earth petroleum geology argument, because if the earth were millions of years old, there should be no overpressured shales. All that pressure should have diminished, because, George, is it not true that in a pressured vessel, the pressure is always looking for a relief valve someplace?
Oh, definitely. Yeah.
And so if you think that you can take a flowing group of rocks, and I brought a rock from my collection to show here. Here is a well-rounded igneous rock that had been transported during the early phases of the flood and lifted up and then transported in this tsunami-like thing, and then it ends up being incorporated in a group of rocks like this in a mesa or a butte. Those are above the covered wagon. There is a series of sandstones and shales in this locality called Scott's Bluff, and there are conglomerates in there, evidence of very rapid movement of rocks, what would be called boulders, actually, this size, moving in the flood waters. So a gravel like this can be explained in a butte or a bluff like this by the receding floodwaters. And the way that this ties in to the whole idea of sequence stratigraphy and this vocabulary that's now popularized by Dr. Tim Clary of Salk, troubled kangaroos attacking zebras today, the Zuni and the Tejas, is when you get up to this part of the record, this is the area of the post-flood world. And so the boundary, the attacking is an A that is pronounced two ways. Absaroka or Absarica is the way I was taught to pronounce it. Don't lose the point and don't lose the criticism of traditional geology. What sequence stratigraphy is saying is you can go worldwide and you can find rocks with trilobites in them very low in the rock record as a packet or a sequence. Forget about Cambrian, Ordovician, Silurian. Forget about 600, 500, 400 million. Forget about all that. Just look at it as a group of yellow rocks, and we'll call those the Sunni sequence. And then above that, we will build, let me flatten the next layer as it would be flattened by the year-long flood. And you got another layer laid on top of that. And then the colors of this oil well that I did on top of that. The petroleum industry identifies these sequences. One of my former students went to work for an oil company in New Orleans. And during a vacation time that we invited he and his family to our house, he brought me some geophysical sections of seismic sections through a group of rocks off the coast of Western Africa. And he said, I've gone to a class, Professor McQueen. They told me how they would pick the unconformities between all these and the traps. What do you think? So we spread it out on my kitchen table, and I took a sheet of paper and began to draw the sequences that I would view as important. And my former student was amazed. He said, you know, that's exactly what we were taught to look for in this class we took. So my final point before we go to our 1 hour break is this. When you look at what is actually in the rock units worldwide, the evolutionary geologists will say, oh, there's a trilobite here, so that shows that it's Cambrian, 600 million years old. Oh, look up here, there's a certain type of dinosaur bone. That proves that it's Cretaceous. Oh, look here, and let's look at a type of plesiopod called MYA. I don't recall the correct pronunciation, Maya maybe. And, oh, that would mean that it is Pleistocene. Well, it turns out that for all the good that this does in petroleum geology, they might as well be paper clips, nuts, and bolts. Exactly. Are you saying a paper clip evolved into a nut and a bolt? No, the evolutionary sequence is meaningless when it comes to pragmatic petroleum geology. George?
I agree, David. We actually did over 2 hour stream on oil exploration with SFT and Steph Harima. I think we covered that subject quite well, but that boulder, the igneous rock boulder that you showed, I mean, that's small in comparison to the ones we actually find out in the open. I mean, we find ones that are tons and tons in that shape.
Yes.
That's. Are you going to take a break now, David, or can I ask you one question?
I'm okay. We're at 57 minutes by my clock, so go ahead and ask a question, my friend.
Okay, I'm surprised that this keeps coming over and over again. It's the question about the origin of granite. Now,
yes.
We've discussed this before, and we looked at the individual ingredients that make the granite, the feldspar, the mica, the quartz, and so on, and they each have a different density. Now, according to secular geology, the Earth was molten at one stage. If it was molten, we would expect those specific elements of the granite to be in order of increasing density. But that's not what we find. So that's another piece of evidence that suggests that the Earth was never a molten ball of rock.
Exactly. Now, this is a granite, and I'm going to put it dangerously close to the camera here. And you'll notice 3 colors. You'll notice white, black, and then a clear color. The clear is quartz, the white is feldspar, and the black is mica, hornblende, and plagioclase. And your point is very well taken. If this, I got to be careful not to drop it on my computer. If this were a molten ball, you would predict as an engineer, George, that all the heavy black minerals would be at the bottom, and then the lighter quartz and feldspar above, correct?
Yeah, well, that was exactly my point. So just based on that one single empirical evidence, Matt Smith, that's empirical evidence, you would have to disregard the theory of the Earth being a molten ball of rock for 500 million years.
Now, recall the argument that I gave in last week's debate on accelerated radioactive decay. Bob Gentry had the viewpoint that if you find a rock that looks like this and you look at the halos in the mica, some of those halos are polonium halos, one of which has a half-life of less than 3 minutes. And so the creationist view that God spoke into existence granites that would have formed the bedrock for the Garden of Eden, for example, that begins to make sense, because it looks to me like something like this cooled as quickly as, George, you're probably old enough to remember the old cameras that had the flash bulb in them.
Oh, yes, I do.
So the flash goes off and it forms this. Now, as we pointed out last week, Dr. Andrew Snelling, Dr. John Baumgartner, and others disagree with aspects of Gentry's idea. But nonetheless, even in that area of disagreement, Dr. Snelling believes that there are several places on Earth that he could take me and we could walk from rocks of the flood, walk for several hours eating our oranges, and then end up in pegmatitic contact metamorphic rocks that would show that that this particular granite formed during the flood. Well, we'll see that another day. The audience needs to recognize that, let's see, how can we most clearly say this? If we were talking only Bible geology and people were coming to us and saying, oh, McQueen, where do you find granite in the Bible? Where do you find sandstone in the Bible? Well, there are some places, but they're not used in that vocabulary. So remember what we talked about at the beginning. The Bible contains answers to everything we need to know. It doesn't contain an answer for everything we want to know. Okay, that's where the science comes in. So if we make the transition from Bible geology to flood geology, we're making a group of assumptions that allows us to say that we can do experiments on powders of quartz and feldspar and mica, and we can look at it. I noticed a question go across the screen about saying, well, Egyptian mummies aren't fossils. May I take up that question after a break?
Of course, yes. And that came in through a super chat. So thank you for the support and donation. Alec, thank you as well. Raymond for the $5 super chat. This isn't a question, Professor McQueen, but the super chat says, if cookie dough melted and solid again, never will become cookie dough or chocolate chip cookie.
Well,
And now I'm in the mood for
it's a clever way to do it. And the consistency of the chocolate chip cookies that Ms. McQueen makes for the grandchildren, it's true. It's very pliable and so forth. But when we get back, George needs to remind me that if we're talking about the bending of rocks into anticlines and synclines, if we would take something as rigid as my cell phone and put pressure on it over year after year after year, what would it do, George? Would it break in two or would it fold?
Oh, we definitely break. It would definitely break. But just to make one point about the cookies, empirically, I believe. Correct me if I'm wrong here, David. I believe granite has a melting temperature of around 3,000 degrees Celsius.
Okay, let's go with that. I don't have that memorized. Go ahead.
Yeah. Well, okay. What they've actually done empirically in the lab is they've heated granite, and when they've allowed it to cool, it actually forms a different substance called rhyolite, which goes to that question about, or not the question, the statement about the cookie dough. Granite, when molten and allowed to cool, does not become granite.
That's exactly right. And this issue of granite, granodiorite, rhyolite, Standing for Truth has encouraged me in the summer to do a session with you, George, called Geology 101 or Flood Geology 101. And we'll define those terms better. That requires about 10 minutes of itself. So with your permission, Standing for Truth, I'll ask you to drop my video feed and I'll be back in 5 minutes.
Yes. It is break time. Well-deserved, Professor McQueen. Some great questions in this first hour. Great presentation, Professor McQueen, and great answers. So we'll go into a 5-minute break. I want to point out as well, now that we're kind of in a intermission, we talked a lot about coal, natural oil, the production of coal and oil, right? And we talked a lot about heat. And there was a question that came in earlier at the beginning about the so-called heat problem. Well, Raw Matt and myself did a full video on it last week. We've talked about it in great detail. I don't think anybody has talked about, the so-called heat problem more than us. Isn't that right, George? So I wanted to make a point that people need to stop looking at it like it's a bug. Okay. And there was a so-called rebuttal to the points Raw Matt and myself were making. And there was no response or no real rebuttal given to my point about the pre-flood world being the perfect battery to suck up and absorb most of that heat. Okay. So people need to start thinking more in terms of heat being an aspect or being a feature of the flood and not actually a bug, because the global flood event, as we've discussed, provides the perfect conditions for that massive amount of heat that's produced during the flood through accelerated nuclear decay, catastrophic plate tectonics, right? Subduction, friction, for example, to be absorbed. And that's where we go back to the coal and oil that we're talking about here, George, where in order to produce coal and oil quickly, there is a process that requires heat. So given the pre-flood world and how it was 90% green and very tropical, okay, that would then be the perfect battery to suck up that heat, because all of that heat can now be used, heat and pressure, to produce all the coal, all the oil that we see today. And there's massive amounts of coal and oil, and therefore that heat and pressure could have been responsible in terms of a mechanism to produce coal and oil in the first place. So, I just want people to stop thinking about it as if it's a bug or a problem. It's a feature. Necessary. Go ahead, George. Go ahead.
Just for the benefit of the audience, there is research currently on that particular issue, the heat issue, but SFT, you've seen some of my preliminary work on this stuff that Jordan had done, and when you consider the ringwoodite and the volume of water that's actually stored in the ringwoodite, when you take that into consideration in combination with the volumes of water in the ocean, I believe from memory, my figures showed that the specific heat of the water alone can absorb 37% of that heat that Jordan mentioned. And in combination to what you said, obviously you need heat to make the coal and the oil and who knows what else. There's a limestone.
I'll interject this, George. Even the heat just to get the plates moving in the first place.
Exactly.
Right?
Yeah, exactly.
So yeah. Go ahead.
And just to touch up on it, I mean, Jordan's whole argument can be defeated with Walt Brown's HPT model. Okay, in that HPT model, Walt Brown suggests that the origin of some or all of the radioactive materials would have formed during the breakup of the deep.
Right.
And we know from Z-pinch experiments that those radioactive elements are formed at the same parent-daughter ratio as you find them naturally today. But also they find that the process is adiabatic. Now, adiabatic is a process where heat isn't produced or expelled. It's sort of like a neutral process. I'll correct myself here. In a previous stream, I actually called it adiabatic, but gave a definition of endothermic. So I apologize for that. But adiabatic means there's no heat produced, no heat expelled. So it's a neutral process. So Jordan's numbers can be defeated purely by citing Walt Brown's HPT model. That's all I have to say to that.
Right.
But as you mentioned, we do need heat to make the interconnecting layers viscous enough so that the tectonic plates can move quickly.
Right.
So it's a plus for us.
It's a plus. It's a good thing.
Yeah, it's a good thing.
It's like God knew through his foreknowledge, right? That this the heat would be perfect for the mechanisms required for the rapid movement of the plates, the rapid formation of coal and oil. Okay. And Sister Joe says, SFT, did you get my question above? Let me go real quick. Chat's moving quick. Oh, here we go. Question, SFT. How do EVOs account for the evidence for accelerated nuclear decay? So that's a good question. So the evidence that I typically point to, and you can chime in on this too, George, has to do with radio halos, fission tracks, helium and zircon crystals, for example. I haven't really seen much in pertaining to the radio halos and fission tracks coming from the evolutionist side because
they have no answer.
Right. They have no answer. There's just too many scars in a short amount of time within the rocks themselves, right, that cannot be explained through uniformitarian processes that show there had to have been one or two periods in Earth's history where nuclear decay was accelerated, greatly accelerated. And I want to point this out. I watched the so-called rebuttal to our video last week on the heat problem, and it's not impressive. These critics are not impressive because still they keep ignoring, George, as you know, they keep ignoring the fact that we have the scars themselves. We have the radio halos, the fission tracks, and we always point out that these lines of evidence suggesting accelerated nuclear decay would be obliterated. We wouldn't have them, okay, because radio halos and fission tracks, for example, are obliterated at relatively low temperatures. So if there was a heat problem where there was no mechanism to remove or absorb the heat or some type of supercooling mechanism, well, guess what? There wouldn't be those observations in the rocks themselves, and they ignore this. They ignore this. In my mind, what they do is It's a quote mine from Dr. Andrew Snelling, because he points this out actually. Yeah, he goes over the numbers. He admits there's going to be a lot of heat produced during the flood, but then he also points out that we shouldn't find the radio halos and fishing tracks in the rocks today if the heat was actually an unsolvable problem, and they just ignore that. Yeah, go ahead, George. What's your answer to that? What are your thoughts, brother?
You can go one step further and say if there was a heat problem, we shouldn't have granite. It should all be rhyolite. We shouldn't have granite. So you can defeat that specific argument just by those empirically found evidences.
Gentlemen, I've been listening to your discussion and fascinated by it. Here's my copy of Bob Gentry's book, and it's called Creation's Tiny Mystery. Now, where'd that come from? That came from a very well-known radiochronologist in America named Brent Dalrymple, who's a longtime critic of what Gentry did. And he was a witness at the Arkansas and Louisiana, I think, creation evolution trial. And he dismissed the radioactive halo argument. Oh, that's just creation's tiny mystery. Well, the more we pursue this and the more we think about, okay, we all recognize that there are aspects of a heat problem in creation week and in the time of the flood. But that heat problem isn't sufficient to dismiss the whole idea of rapid radioactive decay, accelerated radioactive decay, leading to catastrophic plate tectonics. So the argument that you guys gave is an excellent argument. May I go back now to one of the questions from the previous hour, talking about, well, McQueen, how in the world would you explain Egyptian pyramids and so forth? Can I take that one up now, George?
Yeah.
Okay. I had a chance several years ago to visit the Chichen Itza archaeological site in Mexico. This is to the west of the Chicxulub meteorite impact area that we've talked about. And this remarkable pyramid must have been after the time of the flood. And so when we talk about the latter part of the flood, the post-flood time, that's a critical bit of information, because no structure this size could have withstood the catastrophic worldwide flood. That applies to Egyptian pyramids, that applies to buildings in the Andes, like Machu Picchu in Peru. And so when you see buildings like this is a post-flood construction. And so people will try to argue with me, and have argued over the years, oh, McQueen, the ancients were not that smart. The ancients were cave dwellers, dragon clubs, took a long time to invent the wheel, all that kind of stuff. Well, ancient man did remarkable things. And so one of the negative aspects of evolutionary geology and how it spills over to evolutionary archaeology and anthropology is it's diminished the genius of ancient man. And there are books that you can find of a title like that, The Genius of Ancient Man, that argues about this. Let's not forget that when we're talking about this time after the flood, the boundary is a critical thing to understand. And let me draw this out on a sheet of paper so that you can better understand that what was happening in eastern Turkey, what Noah saw with his own eyes in the last month of the flood that he saw. Here is Mount Ararat in eastern Turkey at 17,000 feet. And let's come over to the state of Texas in the United States across the Atlantic Ocean. And let's talk about the latter part of the flood. There is Noah's Ark resting on this, what is now a 17,000 foot mountain. And Noah very carefully observed by sending out birds when an olive leaf was brought back and how much time it took for the waters to recede. And so he saw, by using these birds, that it would take several weeks, several months for things to dry up. Well, that's what he saw in eastern Turkey. When you come over to Texas in the United States, what might have been happening there? Could there have been huge floating mats of vegetation that come to form the brown coal deposits of East Texas going on there at the same time? What is the Bible mandate? What do we know? Well, what we know is after 1 year, recall that everyone had a birthday on the ark. After 1 year, when Noah and his wife and his sons and their wives, when the 8 people got off the ark, they must have been the only people still alive. 100 million people perhaps died in the events of the flood. And an additional millions of animals died in the time of the flood. And so when we come to this post-flood world, we have to realize that there are some constraints that are put on us by the Bible. And so certainly when we look at what is happening in Genesis 8 and 9 and 10, building up to the time of the Tower of Babel in Genesis chapter 11, there's a lot going on, and the focus is in that part of the world. That doesn't mean that mountain building, uplift, and down warp and so forth wasn't happening in the Rocky Mountains and in the Atlas Mountains of Morocco. And so you've got to have a worldwide perspective on this. Do you see where I'm driving with this, George?
Yeah. I'd like to add something. It sort of fits the evolutionary timescale to refer to the ancients as dumb people. Whereas when we show examples of these pyramids, that takes a lot of engineering knowledge to build that. And even today, David, I, as an engineer, cannot figure out how they actually lifted those blocks, weighing so many tons at that height. No way. Actually, I haven't heard a plausible answer to that from anyone.
Yeah. Well, I would challenge Standing for Truth and also you, George, to vacation in the Caribbean and actually go on a tour of Chichen Itza. It's fascinating. The tour guide will stand at the bottom of the pyramid, and he'll have the 20 people clap. And when it echoes, this is acoustical engineering. When it echoes off of the pyramid, it comes back, oi, oi, oi. So you've got, and then it comes back, oi, oi, oi. The Mayan culture drew pictures of what to me looked like pteranodons and pterodactyls that they saw that made that kind of noise. And if you know anything about Mayan archaeology, you know that they have gods that are flying serpents and so forth. And so a lot of this fits in a way that the evolutionary community, and your point's very well taken, the mechanical engineering, the structural, the architecture of these pyramids indicate a very sophisticated knowledge that was carried on board the ark, disseminated through Shem, Ham, and Japheth?
It goes further than just engineering knowledge, David. If you've ever been to Greece, go and visit some of the ancient amphitheaters. And
Yes.
if you want to test it out, stand at the stage, have someone climb the very top of the tiers,
Yes.
and ask the person down at the stage to whisper. I guarantee you, I've done it myself. I've heard it. I was at the very top tier of the amphitheater. Our tour guide whispered at the stage, and we could hear her at the very top of the pier. Now, that kind of knowledge, it's not just engineering and architecture. There's more than just that in designing a structure like that.
Yeah. Well, next year, the three of us will have to meet in Athens, and you'll have to take us and show us some of this stuff. Very, very good stuff. What is our next question, Standing for Truth, that's come through the super chat?
I've got quite a few of them.
Yeah, I've saved a ton of questions. We've had a lot of good questions from the audience, so I'm not too sure if you wanted me to go to a few more questions, Professor McQueen, or if you had a couple.
Yeah, why don't we? We're at the 20-minute after the hour mark, so we have more time. Let's go ahead and go to a question from the audience, and then George has got some questions. I still want him to discuss more about carbon-14 and volcanic issues, but go ahead, Standing for Truth.
Yeah.
Okay. Well, I've got a question here. I'm just going to go right back to the beginning then, Professor McQueen. Let me see. Question here from Chris Peacock. His question is, what does David McQueen think about the Younger Dryas impact that hit the northern ice cap, causing a lot of the floods we hear about?
Okay. As this Geology Emphasis Week goes on, Michael Ord is going to talk about the Ice Age, but I will make this comment. In the centuries after the flood, sheets of ice, illustrated by my white paper here, flowed over the rocks of the Great Flood, and they would pick up enormous boulders from that and carry them down in the ice. And so if you go to areas of Canada and Northern Europe, you will find these boulders that are called erratics there. Now, the question has to do, if you go north of Ohio, if you go north of southern Canada and go all the way up to the North Polar region and the South Polar region, there were meteorite impacts there, and some creation geologists and certainly some deep time geologists realize that if you have a meteorite impact in that area of Canada, some people believe in the Hudson Bay area there's a meteorite impact structure there. At any rate, that would break up the rocks. Would break up the ice, and there'd be a tremendous amount of heat involved in that impact, and it would cause water to flow. I would put that to be in the post-flood time. Okay.
Well, great response, Professor McQueen. And I'll go right to the next one because there's a lot here, which is awesome. We have a great interactive chat with a lot of great points, comments, and questions coming through. So everybody's loving this, Professor McQueen. You are a fan favorite. So thanks again for all you do for us.
Well, that's
David.
kind of you. Thank you, sir.
My pleasure. So question from Alec Cox. The boundary for the lake of water that filled the Kaibab Plateau, how far north does it extend? Into Montana or more south? Question mark.
Okay. Over the last 2 years, I've worked with Dr. Steve Austin and Ed Hollerwood on a model for the erosion of the Grand Canyon that involves the spillover from a impounded lake that was called Lake Hopi. Now, to show you, again, I want to constantly emphasize the fact that even though there may be 100 university-trained flood geologists worldwide, that doesn't mean that all 100 of us agree on every point. Let me give you an example. My colleague at ICR that wrote this book, Dr. Tim Clary, disagrees with me and Austin and Ed, and he thinks that there was another explanation that doesn't involve spillover for the erosion of the Grand Canyon. Without looking back, I can't remember how far north it goes, but I can tell the Standing for Truth audience how to find it. If you will go to the internet and do a search on Steve Austin, and then Ed is the secondary author, I'm the third author. Andrew Snelling edits a online journal that has our extensive paper on it. It prints out to 50 or 60 pages, depending on what font you use. And it's got copious references that Dr. Austin's put together. So do some research on that, and it'll show you how far north it goes.
I've seen your paper on Answers in Genesis recently.
Good.
And like you said, it's very lengthy. I think it comes out to about 50 pages, and it's extremely informative. So I'll put that in the description box of this video when we're done for people to look at.
George, you want to make a brief comment about what we have talked about your research regarding carbon-14, volcanoes, and trees?
Yeah, I'd like to share the screen, please, SFT. So just bear with me for a sec.
Of course.
I'm getting to be a real whiz kid on this. Okay.
You mastered. Actually, George, before you go, I just wanted to thank Raymond for the $5 super chat. He says, "Where is our brother Org? Org's a critic. We want his geology objections." So, yes, thank you for the support. Thank you for the super chat. And I want to point out, as Professor McQueen was saying earlier, so we've got a ton of great debates coming up for April, but we're working on some debates for May and the summer. Specifically, hopefully, some debates on some geology-related topics. So put the word out there. We're looking for some evolutionists or some critics, some strong evolutionists to defend uniformitarianism and hopefully debate a topic pertaining to the Genesis flood with Professor McQueen. So reach out to me. As you know, we are always hosting debates and discussions. So
yeah, I would enjoy that. I hope we can do that in July.
Okay. Can you see my screen?
Yes, sir.
Yes.
Okay, for those in the audience, please take note of the title of that particular article, because whenever I try and put a link in YouTube, for some reason it gets removed. I don't know whether that's their algorithm or whether they won't allow links anymore, but just take note of that. And I'm going to read. You can actually read the entire article yourself, but I'm going to read some excerpts of it. Right. Just take note of what I've said. Volcanoes can tell big lies with big consequences. It's not just volcanoes that do that, by the way. A number of other people do that too. Okay, so what you'll find there, it says radiocarbon dating of organic material is based on the concentrations of radioactive carbon-14 in a sample remaining after the organism's death, which is something that we've known. Over the past 2 decades, the method has been refined greatly by combining it with dendrochronology. I'll talk about dendrochronology a little bit later, which is the study of the environmental effects on the width of true rings through time. Radiocarbon dating of true rings records records has allowed scientists to construct a reliable record of the concentration of carbon-14 in the atmosphere through time. In principle, they say, I've lost myself now. In principle, this composite record allows eruptions to be dated by matching the wiggly trace of carbon-14 in a tree killed by an eruption to the wiggly trace of atmospheric carbon-14 from the reference curve. You can check what wiggle match means from Wikipedia. Scientists presently use wiggle match dating as a method of choice for eruption dating, but the technique is not valid if carbon dioxide gas from a volcano is affecting a tree's version of the wiggle. Just take note of that. It's not valid if carbon dioxide gas from the volcano is affecting a tree's version of the wiggle. Okay, this enlarged influence of volcano can be explained by an influence of groundwater beneath the lake and its surroundings. The topo wiggle match tree grew in a dense forest in swampy land where volcanic carbon dioxide was seeping out of the ground and was incorporated in the trees. The ratio of carbon-13 to carbon-12, the two, which are the two stable isotopes of carbon, in the modern water of Lake Tapu and Wakatu River tells us that volcanic carbon dioxide is getting into the groundwater from an underlying magma body. And this is the diagram they show there. You can see those red arrows. That's your carbon dioxide percolating through the groundwater system. That's absorbed into the trees, giving you a false indication of the ratio of carbon-14 to carbon-12. Okay, so the last bit there says the dilution of atmospheric carbon-14 by volcanic carbon made the radiocarbon dates for tree material from the topo eruption appear somewhere between 40 and 300 years too old. Now, if I'll just stop sharing and I'll explain a few things. Now, what I found with this whole business with dendrochronology, I've got a friend of mine, a Facebook friend of mine, who sent me some information. This is empirical science now, guys. Listen, he apparently planted 3 silver birch trees, so they're all the same species. He planted them at the same time within his own block of land, within 10 to 12 meters of each other. So they've all had the same watering. They're in the same substructure, soil. And listen to this. The 3 of them grew in different rates. One was, when he measured it at 1 meter high from the ground, one tree was 3.5 centimeters thick in diameter. The other one was just over 7 centimeters, and the third one was 15 centimeters. So there's a variation in tree diameter of the same species of tree that varied from 3.5 centimeters to 15 centimeters, all in the same period. To go further,
let me let George catch his breath, and I want you to do an experiment. Go get a cup of water like I have here, and open up a carbonated drink like Coca-Cola, or drop a Alka-Seltzer in it, and you will see the bubbles form. This is an analogy to the diagram that George showed us, where the CO2 moves out of the aquifer and up through and ends up actually screwing up, damaging the statistics of dendrochronology. Right, George?
Yeah, yes. Before people start to pinpoint on silverbird, say, oh, that's just one species. Well, this friend of mine actually went into the street where his house is located, and the street trees are actually a different species. They're called pin oaks. And even in those pin oaks, he measured the diameter of the trees at 1 meter from the ground, and he found varying diameters of the pin oaks as well. This is why I don't place any credence on dendrochronology, but also because the carbon 14 to carbon 12 ratios that they look at can also vary as well. So when they show you these graphs, these nice fitting graphs, they just cherry pick that data to make it look really impressive. So
Okay.
I don't, yeah.
Yeah. Let me,
Go ahead.
We're at an hour 40 now, and I want to address one other thing here that we had talked about earlier. A lot of people that try to simplify evidence for flood geology will say, like, oh, we see evidence of the global flood when we find sea fossils on mountaintops. So here is my pre-flood largest mountain, 10,000 feet tall in the pre-flood. And then there's trees to show I'm drawing a cross section. And then I'm going to pull back and show Mount Everest. And everyone knows it's a lot taller than 10,000 feet, right? Well, it's true that since Hillary climbed it all those years ago, people have found rocks as you go up Everest that have marine fossils in them. But people think about it incorrectly. And let me show you the correct way to think about it. The rocks of the Great Flood were laid down horizontally as the floodwaters receded. And then in the mountain building, as India pressed up against China, these flat-lying rocks, in the case of Everest, were tilted up like this. So you can imagine a mountain climber going up and then going down the other side of Everest. They're not finding they're not finding fossils that have been lifted up and then stuck on the outside of Everest. They are units within Everest that are eroding away. So that's what I was taught to call a pet peeve. It's a burr that gets under my saddle. You understand what I'm saying, standing for truth?
Yes, I do.
And so just be careful about that.
Standing, can I finish my point on the dendrochronology? What
yes,
they found?
Yes. And George, I just want to say one thing too. When you're done finishing your point, I got a super chat recently with a question attached to it. So I want to make sure I get to the super chat. Go ahead, Brother George.
Okay, what they found in that study is when they looked at trees closer to the caldera, that's the edge of the volcano, and this is the first time they've ever done this. They actually went 30 kilometers away and looked at the ratios of C14 to carbon dioxide, and they found varying differences between the trees that were closer to the caldera to those that were 30 kilometers away. That just adds to that argument about the carbon dioxide that was probably taken up by the tree through the groundwater. So the dendrochronology is by no way an exact science. It isn't. There's just so many discrepancies with it that they don't actually tell you. Like we keep saying, they don't report the discordant data. They cherry pick their stuff to prove their narrative.
Right. Amen. And there's so much discordant data as well that typically they don't want to talk about or even bring up in the first place.
But keep in mind what my old statistics professor used to say. There are liars, there are big liars, and then there are statisticians. So statistics can be made to cherry pick data. Standing for truth?
Amen. Amen. Well said.
The other thing with statistics is you can make statistics say anything you want to. All you got to do is make sure you pick the right questions.
Yeah.
Awesome. So I've got a super chat that came in here, $10 from Dr. James Carter. I appreciate the support, brother, and we look forward to having you on again soon. We're going to be doing a second part to our abiogenesis series. Last month we had Dr. Carter and Dr. Hayes on, so we're going to be continuing that series at the end of the month. So his super chat is a question for you, Professor McQueen. Do you think petroleum degradation, both chemically and via microbes, would outpace formation if the Earth is millions of years old?
Oh,
Yes.
good question. Good question.
Excellent point. In the summer, I want to give a whole presentation on research I began 40 years ago on a chemical called porphyrin, which is found in crude oil. Now, you have a porphyrin in your body, standing for truth, and you have a porphyrin growing in your grass, George, there in Australia. Hemoglobin, or the heme molecule in our blood, is a porphyrin, tetrapyrrole structure, and chlorophyll also is a tetrapyrrole structure. And the research by a group of two men that are called Tissot and Velta. You can Google me on ICR.org, and you can find the essay I wrote in the 80s that deal with the origin of petroleum. And you can also go to Dr. Andrew Snelling's big 2-volume book, and he's got a section in it that deals with the origin of crude oil and updates this Tissot and Velta argument. The answer to your super chat is that you're absolutely right. If this crude oil was in the ground for millions of years, having been slowly deposited, not cut off from oxygen, not cut off from bacteria, it would have been eaten up, and we would all have to be running our cars on solar cells, which would be an industrial revolution nightmare.
That's another piece of evidence, David, that says whatever that oil came from had to be buried very quickly.
Exactly.
Under great pressure, and the oxygen would have had to be removed. Otherwise, you wouldn't have had the oil.
So I thank the good doctor for his question there.
Yeah.
Well, thank you for the question, James, and thank you for the great answer, David. George, unless you had anything else you wanted to say, I can.
Yeah, I've got
another one. Yeah, go ahead, brother. Go ahead.
I've got one question. I think it's a good one actually to cover, but I need to share my screen so that David can actually read it.
Yeah, and while he does that, let me make an offer that is based on this week-long discussion by the three of us. If you will send your name and address to Standing for Truth, the first 3 people that send your name and address, I will send you an autographed and inscribed copy of my book, which I just happen to have right here beside me, called The Mineral Book. And it's got a section in it back on page 69 that deals with some of the issues that we're talking about. So Standing for Truth, watch your email over the next week, and first 3 people that come through, you send me their name and address, and we will consider this a Geology Week bonus. 3 of us talking, like 3 books.
Oh, David, I had to buy that book.
Well, when I come to Australia or when we meet in Athens, Greece, you bring it in your suitcase. I'll autograph it for you.
Yeah, beautiful, yeah.
I got to say, I'm looking forward to my autograph copy. Real quick, George. So I like the sounds of that, Professor McQueen, and it's a Genesis Flood Week bonus. So I'm going to put my email in the chat, and the first 3 that send me an email get an autographed copy of Professor McQueen's book. So
okay, George, go on, take it back now. Share your screen and show us.
Check your email, Standing. I just sent you an email. No. Okay,
George, you sent me 3 emails. You get 3 books. Okay, here we go. Share screen.
All right, I wouldn't even bother with the first one. I don't like people that say things like that. But in the second part of it, he says, successive dryings of the Mediterranean produced hundreds of meters of evaporites. Not only did evaporites form, but also land deposits like sun-baked mud cracks, wind-blown sand, and subcar anhydrite nodules. Since algae can only grow where sunlight reaches, the stromatolites, a common algae deposit found in deep sea core samples, show that the Mediterranean seafloor, now 2 miles deep, was once dry land.
Okay, let me respond to that. There are 5 different issues there. I will pick only one, and that's the issue of salt deposits or evaporites in the Mediterranean basin. In the 1980s, one of my graduate students at the Institute for Creation Research graduate school named David McQueen did a study of evaporites in the Gulf of Mexico south of New Orleans. There's a very famous, very thick salt deposit there called the Luan salt. And there's ample evidence that that wasn't an evaporite from oceans coming and going over tens of millions of years, but rather it had a hydrothermal origin. Now, does that mean that there was no salt evaporating on the one world continent in the days of Adam and Eve and the hundreds of years leading up to the flood? Of course not. So there are some legitimate evaporites, but to present an argument that flood geology must not be true based on the presence of stromatolitic groups, stromatolitic mounds, some of which may not be algal at all, but that's a story for another time. Let's focus on the evaporites. We're coming up to the last 10 minutes here, so I'll simply say that the evaporites can have a hydrothermal origin. And notice in the vocabulary that George and I use, we keep coming back to ways that this heat problem suggested by Jordan can be dealt with. It does indeed take heat to mature crude oil. It does indeed take hydrothermal or heated brines to produce the hydrothermal evaporite layers. So the more we talk, George, our list goes from 5 to 10 and beyond ways that we can have what people that have suffered through thermodynamics call heat sinks.
Heat sinks. Heat sinks.
Yeah, heat sinks. Yeah, good.
And I think it all comes down to us looking at it more like, as I was saying earlier, a feature and an aspect. And all of a sudden, as Professor McQueen said, we've got, 5 different heat sinks, 10 different heat sinks, eventually an unlimited amount. So good point. And I'm sorry to cut you off, George. Go ahead, brother.
Yeah, I was just going to add to what David was saying, because I watched this Kurt Wise video about, correct me here, David, whether I'm actually saying this correctly, seismatites. It's a cone.
Okay. That's a part. I think you're pronouncing the word seismatite, which is the result of a earthquake.
Yes.
Hitting muds and fat clays and jarring them and producing. I think Steve Austin has studied some of these in Israel, if I recall. But go ahead.
Yes, correct. What they found when they do find the seismatites, they can actually correlate them to the strength of the earthquake. But I think Kurt, I can't remember the actual location of this place, but he found one that was either 6 feet or 60 feet. Usually you find them like maybe an inch or two.
Yeah, a few centimeters. Yes.
But to find one so big through rock strata that was obviously, according to secular geology, hundreds of millions of years through hard rock, that's almost impossible. And the fact that this seismatite was so huge suggested that that was one massive volcano or earthquake eruption
Yes.
that caused it. And we keep going back to this. The initial the breakup of the deep was catastrophic. You would have had volcanoes, earthquakes of immeasurable measure and quantity. So
yes,
yeah, how do they explain that?
well, that is an evidence for catastrophic geologic activity. We're coming up on the 2-hour break, and so can I make my summary comments and then turn it over to you and George, Standing for Truth?
Absolutely. So what I'm going to do as well is, because we've got questions for forever, essentially. So I'm going to save, I've got the questions saved on my phone. Therefore, the next time we have you on, Professor McQueen, we've always got a stash of questions for you. I want to thank Raymond for the super sticker. And also, looks like I've got some emails already. Emails are flying in,
good.
Professor McQueen.
That's good.
Looks like I've got
email them to me when the time comes.
I will. It looks like I've got 2 of the 3. So whoever's the third one, there's the prize. So go ahead, Professor McQueen.
The mailing of these books, the taking away of my valuable time from washing dishes for Mrs. McQueen, this is $100 value here, these 3 books, but we won't go into that. Let's get serious for a moment. We've argued all along that the Bible can be trusted. So we've argued forward from Genesis to the book of John. So we've said, since there's evidence for young earth creationism, that shows the Bible is true. And so when we go to the book of John and it talks about Jesus as Lord, then we can trust that. Well, since it's Easter Monday in Canada, and we've got the red and the white of Jesus's blood, his atonement, his death, his real burial of a dead man, and the resurrection behind me here, let's now take it in reverse. One of the most, how would you say, one of the bits of Bible archaeology that is very strong evidence for the truth of the Bible is the evidence of the resurrection. Hundreds of people saw the Lord Jesus after he was raised from the dead. The scribes and Pharisees and Pilate and the Romans, if somebody had stolen the body and took it someplace, you can be sure that the scribes, the Pharisees, the Sadducees, they had decades to find it. They never found the body of Christ. So now let's do the reverse argument. Since we have proved that Jesus is the risen Lord and is alive right now at the right hand of God, we can work the sequence backwards. We've said many times that Jesus is the creator, the savior, and the coming king. Well, if there's evidence right in the middle dealing with the cross of Christ, I can get a cross here, dealing with the cross of Christ, proving the resurrection, then we can go backwards and say, well, we can trust the Bible, what it records in 30 AD. Why can't we trust it 4,000 years earlier? Makes sense, gentlemen?
Definitely.
Amen. Amen, Professor McQueen.
And happy Easter to all, by the way.
And with that comment, gentlemen, I will go ahead and X out of the chat and look forward to our discussion next week sometime, Standing for Truth.
Right.
Okay?
Yep.
Amen. Amen. I look forward to next week, Professor McQueen. Thank you. As always, you are a blessing. Some great answers to some great questions, Professor McQueen. So we will see you next
I look
week.
forward to listening to my 2 colleagues as the week goes on, Brother Sal and Mike Ord. Goodbye, gentlemen.
Goodbye,
See you, David.
Brother McQueen. So I want to thank the audience. Yeah, we just hit the 2-hour mark. So thank you so much for all the support, super stickers, super chats. You guys are the reason why we are able to do things like this. The Genesis Flood Week in the summer, we want to do a Standing for Truth creation conference where we've got all sorts of topics pertaining to creation and going into the genetics, geology, biology, astronomy, so on and so forth. So your support is helping us do these awesome events. So I hope this was informative to everybody. I want to remind you this Wednesday, same time, 4:00 EST, Michael J. Ord will be here for a presentation on the post-flood ice age, followed by questions from you guys, just like we did today. And then the Thursday, we've got Sal Jardina, who will be with us here as well all week between Professor McQueen, Michael J. Ord, and Sal, all experts on these topics. So these are the men that you're going to want to ask these types of questions to. So George, any final words, brother?
Yeah, sneak preview. We're trying to get John McKay back on the stream, but I'm having some negotiation issues. I'm trying to get him down from his $1 million appearance fee. I think that's a bit too much for us, isn't it?
Well, we've had him on. Well, we've had John McKay on twice. That's $2 million. So now we got to raise another $1 million to get him on the third time.
Yeah, exactly.
So anybody new to the channel, go to the playlist section. I've organized it nicely. You can find answers to pretty much every objection to Young Earth creation. Check out the interviews hosted by SFT, and you can find over 40 interviews with top PhDs on every subject possible. So we're doing it for you guys. We are here to serve. I think we've got about 1,200 videos on the channel. Also, check out, we've got a black and white version of my new book on independent origins, as well as the colored edition. I'm overwhelmed by how many people are picking it up and enjoying it. So the feedback is great.
Joke.
And Sal in the chat, Evidence and Reason, says that's the other brother Sal, not me, Sal Jardina. I'm Sal Cordova. So we've got two brother Sals, one in geology and one in physics. Brother Cordova, correct me if I'm wrong, but he's a physics guy. So we've got experts on every topic, every field. So thanks again. And George, I know you're about to say a joke. You got to say 2 jokes because you skipped the joke at the introduction, brother. Go ahead. Go ahead.
No, I'll tell you one joke. I just remembered this joke. There's a Japanese emperor who's worried about being assassinated. So he puts out an ad in the paper to get some bodyguards. And he specifically says they must be master swordsmen. So 3 people applied: a Japanese samurai, a master swordsman from Korea, and a master swordsman from Israel. So he brings in the first one, the Japanese samurai, and he says, hello, goes through the interview processes. He shows him this matchbox. He says, in this matchbox, he says, I have a fly. I'm going to let him go, and you do your thing with your mastery, and we'll see how you go. So the emperor lets out the fly. Bzzz, there he goes in the sky. The samurai pulls out his sword and goes, swish, swish, and chops the fly into 4 pieces. The emperor's very impressed. He says, thank you very much. The Korean master swordsman comes in, goes through the same process, opens the matchbox, lets the fly out, swishes his sword out, and he goes, swish, 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 swish. 8 pieces. 8 pieces. The emperor's really, really impressed. So in comes the swordsman from Israel, and he goes through the same interview process, opens up the matchbox, lets the fly out. The swordsman from Israel pulls out his sword and goes, swish, 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 swish. And the fly is still buzzing around. And the empress looks at the Israeli and says, I'm bemused. He goes, what happened? You didn't kill the fly. He goes, no. He says, circumcision, not fatal.
All right, you made up for your lack of joke in the introduction, George. I think I think we've got our George back. So, George, we got to get you. We got to get you better because we got a big week ahead of us, brother, and I suspect a big summer ahead of us as well. So, anyways, guys, thanks so much in the chat. We will see you Wednesday with Michael J. Ord and Thursday with Sal Jardina. Also, we've got a debate on Saturday, I believe it is. Check the upcoming live stream section, guys, for the exact days and times for these events. But we got a debate between Nephilim Free and Mark Reed on evidence for the Christian God on Saturday. Next week, we've got Dr. Dan Biddle from Genesis Apologetics, who puts out some great videos. Their website is awesome. They touch on pretty well all the topics, kind of like we do. He's going to be with us. He's going to give a brief presentation on human evolution. Him and I have been talking back and forth through email, so I am pumped. He's going to give a presentation on human evolution. Then we're going to have an audience Q&A, some questions from us. We're going to demolish human evolution. We're going to touch on all the so-called transitional forms. Okay, guys, so you're definitely going to want to be here for that one. And then the following week, we've got the big debate between Joseph Hubbard and Taylor, who goes by Snake Was Right on YouTube, on young Earth creation and the global flood. So lots to look forward to. George, you get the final words, brother, and then we're going to shut it down.
Thanks, SFT. Yeah, look, sorry, but my voice might be a bit croaky. I've had a kind of nasty cold for the last week and a half, but I spent it out in the mountains with the clean air and the sunshine, and I'm getting better. So a happy Easter to everyone, and God bless you all.
Happy Easter. God bless everybody. I'll be praying for you, George. You sounded good today, though. You brought up some great points. Love the screen share. You're a screen share master now. So keep up the good work, George. When I say you are the award-winning co-host, I mean that. And there should be an award making its way to Australia at some point. So thanks so much, everybody. Yeah, go ahead, George.
I keep looking at the mailbox. There's nothing there.
Nothing yet.
Nothing.
I'm going to personally deliver it to you, George. And then I'll have some of that famous pizza you're constantly sending me pictures of over WhatsApp. Every time you send me a picture of that amazing looking pizza, I tell my wife, honey, we got to order pizza tonight. So you're feeding my addiction, brother.
I was gonna send you a picture of the smorgasbord we had in the mountains a couple of days ago, but I thought I won't rub it in.
Yeah. So is that the secret behind those biceps of yours? All that pizza?
Well, it's that plus all the work my friends make me do for them.
Right. And all the work I make you do as well for the ministry, right?
Yeah.
You're working overtime, brother. You're working overtime. Anyways, thanks so much, everybody. We'll see you back on Wednesday.
And SFT is out.